Hello there and welcome back to another video. In today's video, I'm bringing the Dell R720 server back out because in this video, we're going to do some stuff with it that it wasn't really intended to do. Now before I get into exactly what we'll be doing with it, let's have a quick rundown of what the server has installed in it, because I'm certain that not everyone here watched my previous video on this machine. Installed in this server is 64GB of DDR3 ECC RAM, as well as two Intel Xeon E5 2650 CPUs. There's also two redundant 750-watt power supplies, and apart from that, there isn't much more to mention that's relevant in this video. Now in my last video on this server, I tried to put a SATA SSD in the front SAS bays of the server, but it didn't work out. And I'd like to say thank you to everyone who informed me that this is because I'd need to configure the RAID controller on the motherboard. I really appreciate that information. However, for today and the things that I'll be doing this time, I'm actually going to hold off on putting the SSD into the SAS bays and configuring the RAID controller. I'm doing this mainly for the sake of simplicity, but also because I still don't have any drive caddies for the server and would rather not have the boot SSD just hanging off its connector in one of the SAS bays. I'll definitely be putting some real SAS drives in the bays in the future though, so thank you to everyone who pointed that out to me because I'll definitely use that information in the future. So today, I just borrowed the SATA connection from the DVD drive to plug in my 128GB SATA SSD, which is what I'll be installing Windows 10 on today. Yep, you heard me right, Windows 10. Is this a good idea? Absolutely not. But today, we're just gonna have a little bit of fun, so we're installing Windows 10 on this server. This server has inbuilt graphics, though they completely suck. This is understandable because it's a server, and servers usually don't have monitors plugged into them all of the time, and also typically aren't used as desktop computers. Therefore, the inbuilt graphics are only good enough to configure the server and really not that much more beyond that. To fix this, I'm going to be putting a dedicated GPU into this server, and the GPU that I've chose to use today is a low-profile RTX 3050 6GB. Why this card, I hear you ask? Well, I bought this card for the sake of using it in some other office PCs in a couple of future videos, and I don't want to buy a second, more powerful card for this server, so we're just going to use this card. Also, it might seem like this 3050 6GB would easily be the bottleneck in nearly anything, because we have dual 8-core 16-thread CPUs, but not to spoil anything, the results were surprising, so before eating the 3050 alive, stick around for a bit to see the results. After positively failing to install the GPU into the server for about 10 minutes, I was ready to boot the server up and start installing Windows. I sometimes test things out off camera before bringing out the camera to record them, just so that things can go a little smoother when I'm working in a much more crowded environment with my lights and tripod. This was one of those times, meaning that I tested installing Windows 10 on the server before filming, and during that test, which was done without the 3050, everything went flawlessly. However, as we're about to see, adding and trying to use a dedicated graphics card on a server like this can cause some odd issues when installing an OS, at least Windows 10. The server defaults to using its inbuilt graphics if it's enabled, which I discovered by plugging in both the VGA cable of my monitor to the iGPU and my monitor's HDMI cable to the 3050 and watching which input it grabbed onto first. After discovering this, I immediately entered the BIOS to disable the integrated graphics on the server. Upon rebooting, I was able to get video out of the 3050. I then loaded into my Ventoy USB that I'd plugged into the server at this point, selected my Windows 10 ISO, and let the server boot. Or at least I let it try to boot. But the Windows installer gave a blue screen of death with the machine check exception code. At this same time, I saw that the server itself was throwing an error message on its inbuilt LCD. It also mentioned a machine check exception, but the part of this error message that I found to be very confounding was the mention that it was due to an internal error on CPU 2. The first thing I tried was rebooting and trying again, but the exact same errors were thrown. I have some upgraded CPUs for this server that I was planning to only bring out later in the video, and I had installed these chips before recording to ensure that they were functional. Right before filming this video, I switched the CPUs back to the old ones, so maybe during that switch something went wrong, and so I decided to reseat both CPUs. This time, the server behaved a tiny bit differently when booting into the Windows 10 installer. Instead of giving a full blue screen, the loading icon froze, the USB drive stopped indicating any activity, and the server LCD gave the CPU internal error, though this time on CPU 1. The CPU error jumping from CPU to CPU was immediately concerning to me, because it could be an indication of a motherboard or firmware issue rather than a CPU issue. At this point, I decided to see if the new CPUs would fix this issue. The new CPUs are a pair of Xeon E5 2695 V2s, which are 12-core 24-thread chips. They're also a generation newer and are almost the fastest chips that this server can take. I was going to buy 2697 V2s, but the 2695 V2s were actually half the price and only seemed to sacrifice a little bit of clock speed. But anyway, with the new chips installed, I tried again, and this time there were no CPU errors. Instead, however, after a while of loading into the Windows installer, the system dropped its video output entirely and stopped pinging the USB drive for data. Even after waiting for a while, the output never came back. I'm going to skip over the next few hours of troubleshooting so that I can give you the rundown of what I discovered was really happening here. Basically, if you want to use a dedicated graphics card in one of these servers for the sake of using it as a workstation, you need to install Windows using only the integrated graphics of the server. The dedicated graphics card can be installed the entire time, you just have to use the iGPU to get Windows installed and set up with drivers for your real GPU. After you have the proper drivers for the dedicated card installed on your new Windows installation, once more, all done through the iGPU, you can then reboot into the BIOS, disable the iGPU, and it shouldn't complain past that point. At least it didn't for me. And also, you cannot change CPUs in the server and have your Windows installation continue to work for whatever reason. I'm not sure why, and there's probably a workaround, but after switching back to the old CPUs, because I'd found my method to install Windows and wanted to get my benchmarks for the old CPUs first, the install that I had created with the 2695 V2s would not boot anymore, so I had to go through the entire install process again using the 2650s, and then it worked. But anyway, after way too long a time, I had my Windows installation ready to be used for testing. The first thing that I will note when using a server like this as a workstation or gaming PC is the boot times. They are pretty bad. It took this server about 3 minutes to boot up, which could be worse, but it is far from ideal, especially with how many restarts Windows seems to require when using it as your OS. I uninstalled a couple of useless apps and then started Cinebench R23. I was going to do R23 and 2024 by the way, however, Cinebench 2024 requires the AVX2 instruction set, which these E5 2650s do not have. In R23, however, the server scored a multi-core score of 8660 points, and in single core, an absolutely astounding 508 points. Now that we have some basic CPU numbers, before I move on to some other benchmarks such as gaming, I have one more synthetic test to run quickly on the system just for sake of comparison. In 3D Mark Time Spy, the system scored an overall score of 4659. With a CPU score of 3935 and a GPU score of 4816. Alright, now it's time to get into some very fun tests, which I've likely hinted at in the thumbnail and the title at this point. Can it game? Now, let me first address, once more, that I am well aware of how bad an idea this is. But again, today we're just having fun, so let's fire up Forza Horizon 5 and get some numbers with the Xeon E5 2650 CPUs. In Forza Horizon 5, at 1080p with 2x MSAA, short motion blur, and the high preset, minus ray tracing, there was a noticeable CPU bottleneck. With an average frame rate of 39.4 FPS, with a 1% low of 31.7 and a 0.1% low of 13.2, the system's performance was underwhelming. However, I think that this is due almost entirely to the poor single-core performance of these Xeons. During the benchmark, it can be seen that our 3056 gig isn't going much above 40 to 50% utilization. The end screen of the benchmark also confirmed my suspected CPU bottleneck when showing that the CPU's average render FPS was 43 with the GPU capable of doing 85. It also blatantly says that we are 0% GPU limited, so there's definitely a CPU bottleneck. Moving on to Spider-Man Remastered, running at 1080p with no resolution scaling and the high preset, we saw an average of 39.1 FPS with 1% and 0.1% lows of 21.1 and 13.1 FPS respectively. Looking at the CPU and GPU usage while running this game, there's clearly less of a CPU bottleneck. However, there still certainly is one. The CPU utilization is not pinned at 100% as it is when observing some CPU bottlenecks. However, in this case, it's not going to show 100% utilization due to the fact that we have 2 CPUs and a total of 16 cores with 32 threads. That's something that a game will never be able to max out. However, the handful of cores that a game will use will be completely maxed out due to the poor single core performance of these CPUs. And that's what's causing our CPU bottleneck. Spider-Man Remastered does support ray tracing, which I wouldn't usually recommend on this card, but I have a suspicion that there will be almost no performance degradation in comparison to our non-ray trace test due to how heavy this CPU bottleneck is. With all the same settings as before, but this time with ray tracing set to high, we saw an average frame rate of 35.8 FPS with a 1% low of 16.9 and a 0.1% low of 12. As I suspected, we didn't drop that much performance in comparison to our non-ray tracing results. However, I still wouldn't call this a great experience. Now in Hitman 3, with the Dartmoor benchmark scene running at 1080p with a mix of mostly high and medium settings and no ray tracing, we got an average frame rate of 18 FPS and pretty terrible 1% and 0.1% lows of 5.3 and 3.5 FPS. Interestingly, the CPU bottleneck seemed to be the most serious it has been yet in this game, with the CPU utilization percentage well into the 40s and the GPU utilization around 30% most of the time. The results with ray tracing enabled are a lot worse than without it, but this seems to be mainly due to the nature of Hitman 3's ray tracing, as it brought even an ARC A750 to its knees. In any case, I still tested it for the fun of it, and the average frame rate was 11.4 FPS, with a 1% low of 4.5 and a 0.1% low of 3.1. There's a bit of a trend that is starting to develop here in the results of these tests. It's pretty clear that these CPUs are heavily bottlenecking the 3050 6GB card in here, which isn't even an absurdly powerful card. This is quite disappointing performance. Now, it is important to keep in mind that a lot of server CPUs aren't really optimized for single core performance, as these servers usually don't run applications that really benefit from super high single core performance. Rather, these chips are designed to have a lot of cores so that they can handle highly multi-threaded workloads very easily. So this lackluster performance isn't that surprising, though it still would be nice if it was a little better. I also tested Satisfactory and Halo Infinite on these old CPUs, but I managed to lose the actual benchmark numbers, so I'll just have to show you some of the gameplay footage and you can take a look at the frame rate. Satisfactory at 1080p medium settings seemed to be mostly hanging out around the 40 FPS mark, though there were a lot of large stutters. Satisfactory is not a very smooth game though, and stutters quite a bit even on high-end hardware, but I will say that it was stuttering an unreasonable amount this time, likely due to the CPUs. Halo Infinite was interestingly one of the more playable games that I ran on this server. At high settings, it was usually around the mid 50 FPS mark and it didn't stutter too bad at all, which I think is quite impressive. I played a little bit of training mode with some bots in an arena map, and apart from the fact that I was trying to aim with a cheap mouse while using the server's top as my mousepad, it was a pretty playable experience. So hopefully you enjoyed seeing some horrible gameplay for these past several seconds, but hey, at least it was actually playable. And that wraps up the gaming tests for this server with these CPUs. However, there is one more thing that I want to try on this server before swapping out the CPUs and benchmarking again, and that is DaVinci Resolve. I'm unsure of whether or not the free version of DaVinci Resolve is NUMA aware, which would be important in this case because we have two CPUs, and if it isn't, it will only use one. In any case, when trying to edit video in DaVinci Resolve, I noticed some very weird performance. First off, the editing performance was absolutely horrible. With my 4K footage on a 4K timeline, I expected this system to offer performance that wouldn't be exceptional, but that should be far better than what you're seeing on screen right now. The system could not even play back the footage on the timeline in real time, let alone two pieces of footage at once. Interestingly, there was seemingly a hard cap on CPU utilization when using DaVinci Resolve. It didn't necessarily seem like it was only using one CPU, but one CPU was being hit harder than the other, and even then, there was some weird limit on its usage, not seeming to go above around 36%. Furthermore, the CPUs were not going above 1.19 GHz while editing in DaVinci. This is well below these CPUs' base clocks, but it seemingly wasn't something caused by a Windows power plan and rather was something weird with DaVinci, because other applications caused the CPUs to turbo up to regular speeds. I'm not 100% sure what's going on here, but this performance was quite disappointing considering we have so many cores. Alright. That wraps up all of the testing that I've done on this server with its old Xeon E5 2650 V1 chips. Now it's time to swap out the CPUs, reinstall Windows, and get to testing with the newer E5 2695 V2s. Starting out with Cinebench R23 again, these new chips managed a multi-core score of 14,889 points, which is massively higher than the score the old CPUs got. In fact, this isn't that far off from what my main gaming PC with its overclocked i9-11900K scores in Cinebench R23. It only took 24 of these Xeon cores to come semi-close to 8 more modern ones, so yeah, if you haven't guessed it already, the single core performance of these chips is still pretty bad, which is confirmed by the 594 points it scored in Cinebench R23 single core. I also ran 3D Mark on this system with the new CPUs, and it managed an overall score of 4523 this time, which is worse than last time. Both the graphics and CPU scores were also lower this time, being 4683 for the GPU compared to our previous 4816, and our CPU score dropped from 3935 to 3790. That's really weird, and I have no idea what's happened there. Back in Forza Horizon 5 with the exact same settings as earlier, those being 1080p native, high preset, no ray tracing, 2x MSAA, and short motion blur, there was only a very minor improvement in our average frame rate, jumping up to 43.7 FPS from 39.4 before. The 1% and 0.1% lows are mostly the same, sitting at 33 and 12.8 FPS respectively. The CPU bottleneck is absolutely still there, as our GPU was nowhere near 100% utilization during this benchmark. Interestingly, in Cinebench R23, we saw an approximately 17% improvement in single core performance, and in our Forza Horizon 5 average frame rate, we saw an approximately 12% improvement. These two numbers are somewhat similar, which is interesting to see, at least I think. In Spider-Man Remastered, with the same settings as on the old CPUs, the new CPUs were able to push 33.3 FPS, which is strangely a lot lower than the 39.1 we saw with the old CPUs. I'm also not sure why this is happening, but I guess Spider-Man just didn't get along with these chips. The 1% and 0.1% lows were 14.4 and 1.3 FPS respectively. After enabling ray tracing in Spider-Man, the average frame rate dropped to 28.3 FPS, once again, a lot lower than what the E5 2650s were able to push. With 1% lows of 15 FPS and 0.1% lows of 2.6 FPS, I'd call this performance hard to use in a game which has a decent bit of fast action, such as this one. In Hitman 3, again with the exact same settings as on the previous CPUs, and this time without ray tracing, the new CPUs put out about 17.8 FPS on average. The lows were, unsurprisingly with that average, quite low, being 6 FPS as our 1% low and 4.5 FPS as our 0.1% low. I would say that this performance was so close to what the old CPUs were able to do that it's honestly just in the margin of error. So interestingly, there doesn't seem to be too much of a difference in performance this time. Turning on ray tracing tanked performance as it always does, but in this case it did draw out a little more of a performance delta than the non-ray trace test did. This time, an average of 13.4 FPS was achieved, which is exactly 2 FPS higher than the old CPU's performance. The lows are kind of meaningless at this level of performance, but I'll read them out anyway. Our 1% low was 5.5 FPS, and the 0.1% low was 3.5 FPS. This time around, I didn't lose the numbers for Satisfactory and Halo Infinite, so let's take a look at the results from those two benchmarks now. In Satisfactory, with the same settings as on the old CPUs, those being medium, we saw an average frame rate of 39.7 FPS with 1% and 0.1% lows of 1.2 and 0.3 FPS. Yeah, Satisfactory is a stuttery game. These lows aren't too much the fault of the system, and this performance seemed to pretty much match the performance of the old CPUs. Although I don't have exact numbers for the old chips, so take that with a grain of salt. In Halo Infinite, with high settings at 1080p, once more exactly the same as on the other set of CPUs, we saw an average of 58.2 FPS in an arena map with a couple of bots. The 1% low was 37.6 FPS and the 0.1% low was 27.4. I find it quite interesting how Halo Infinite seems to be the game that offers the best performance out of all the games I've tested here, as it's not necessarily a game that I would consider to be stupidly easy to run. Its recommended requirements are an RTX 2070. Now that wraps up the gaming benchmarks once more, and thank goodness, because I hate reading out all of those numbers. So let's touch on this system in DaVinci Resolve with these new chips. But minor spoiler alert, there's not much new in terms of behavior and performance. In DaVinci Resolve this time around, we were actually able to play back some footage at real time, which is greatly impressive compared to the previous configuration. However, 2 clips at once was still a challenge, and when performing very CPU heavy tasks, like exporting, there was that same strange CPU utilization behavior. We didn't seem to want to go above 36% overall utilization, and it seems like most of our work was being done on only one NUMA node. But interestingly, we weren't fully utilizing that node, only about 70 to 80% of it. Just some really weird stuff with CPU utilization. If you know what's going on here, please let me know, as I'm quite interested to know what's happened. Even though that performance was slightly better, it was still disappointing because I was actually really hoping that the system would be decent in a video editor, as I figured it could be cool to set it up as a remote desktop for video editing on the go. Well, that's all that I have for you today. Just a bit of messing around on this system and discovering that it kind of sucks for these applications. Though that's not too surprising, as it's definitely not engineered to run video games or video editors for that matter. I hope that you were able to at least enjoy this video and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.